everyone, in this video I'm going to talk about the biotechnology we have in AP Bio. So the first one I'm going to talk about is gel electrophoresis. And what happens in gel electrophoresis is you're going to separate molecules based on different sizes and charge. So remember that the DNA is negatively charged thanks to that phosphate group. And so you're going to attract the DNA by having a positive charge on the other end. The next type of biotechnology that I want to talk about is polymerase chain reaction, PCR. And in this case, you could think of it as a copy machine for making copies of small fragments of DNA. Usually DNA you would either find at a crime scene, but the thing about the PCR, and when you're making the copy of the DNA, is you're going to use something called a thermocycler. And with the thermocycler, it's going to use heat to separate the two strands of the DNA. So because of this, we have to use a special form of polymerase called the Taq polymerase, because the Taq organism, thermo something, is adapted to live in high heat temperatures. So the polymerases and the enzymes that are involved in DNA replication won't denature because this organism is adapted to higher temperatures compared to you or me or plants or anything else that might live in normal temperatures. The next one we're going to talk about is Crispr. Crispr is a way to kind of find and replace DNA. It is enzymes. And it was discovered fairly recently, and the woman who was part of a group who discovered CRISPR actually won the Nobel Peace Prize in 2021. But thanks to these enzymes, you can find specific sections of DNA, cut them out, and replace them with other pieces. So this might have, in the future, this might have some therapeutic value in helping people with genetic disorders. The last one I'm going to talk about, and the one I'm going to focus on the most, is your bacterial transformation. This is probably the most This is probably the one that is most important, as there are the majority of the questions on College Board's websites are going to involve either bacterial transformation, number 1, number 2, gel electrophoresis, number 3, PCR, and CRISPR. Well, it's still relatively new. At least in 2023 when this video was made. So at this point there really aren't questions about CRISPR yet, but that may be coming soon. So for the bacterial transformation, I'm going to focus on the end results of the experiment where we have 4 petri dishes. And we're going to talk about what's happening in each petri dish and what we're testing for. So if you want to kind of think about this in halves, these 2 halves of the petri dishes are not going to contain the antibiotic. These 2 halves of the petri dish will contain antibiotics. You can also think of it halves this way, where this top half right here are the untransformed bacteria, and then this bottom half down here is also the untransformed, or is the transformed bacteria. So in this first one, we're going to test to see, is the bacteria alive? There's no antibiotics at this point, and we're just checking to see if what the company sent us is alive. We call this the wild type bacteria. And hopefully, if they sent us the right shipment, what we would see is a complete growth of bacteria covering the entire surface of this petri dish. In the second experiment here, what we want to test for, remember on this side right here we have no antibiotics, but on this side right here we do have antibiotics. So we're going to add the antibiotics, and hopefully what we see is no growth of the bacteria. If we see growth of the bacteria anywhere in here, it means that the bacteria was already resistant to the antibiotic, and we're trying to make that happen using transformation. So you go through the transformation process, and it might, in the process of doing the thermal shock to open the membrane, you might accidentally kill your bacteria. So we got to check to see, after the process, with both of these are going to be transformed bacteria, we got to check to see if it's even still alive. So we're going to do that in this one right here. So in this one, we have the transformed bacteria. Again, we still have no antibiotics on this side, no antibiotics. And if they survived, we again should see growth on this plate. If you see no growth on this plate, that means you accidentally killed all your bacteria in the transformation experiment. That's supposed to say transformed. Once you have confirmed that the bacteria survived the transformation process, the last step here is going to be testing to see if any of the bacteria actually transformed. If they actually took in the plasmid that was added that should give them their new superpower, which is antibiotic resistance. So, this plate here has antibiotics in it, and if all went well, you would see small colonies of bacteria growing. And the reason you would only have small colonies instead of entire covered areas is because not all the bacteria are going to take in the plasmid. And even if they take in the plasmid, they may not incorporate it. So not all the bacteria are being transformed. So in this one, you would have your transformed bacteria, which should now be resistant to the antibiotic. In this experiment, overall, you could consider this one the control. However, this one over here, we would call it as a negative control, because what we want to do is ensure that no growth is happening on this plate. I hope this video was helpful. Thanks for watching. Bye!